Hello students. So in the previous discussions we discussed about arithmetic progression, we learnt about general terminologies, various important tips, and we found a very good concept regarding arithmetic mean. Based on similar line, we are going to discuss about the geometric progression, and as you can see the similar distribution of pedagogy is being followed, and again this part of journey is again divided in two parts. So in first part of this we are going to study about the general terminologies, about the GP, and we are going to learn that how to find sum of n terms of a GP. So let us start with this part. So let's see what a geometric progression is. So as written, a geometric progression is a sequence whose first term is non-zero and each of whose succeeding term is r times the preceding term. So in the AP we talked about a common difference. Here we will see a common ratio. So I'd like to mention that in the AP we were concerned about addition and subtraction. Here we are seeing that when we are making the term r times, we are basically multiplying a constant to it, to preceding term. Okay, and it's written that where r is some fixed. Two things to keep in mind geometric progression, that we have to keep ourselves away from 0. The a should not be equal to 0. Why? Because if a is 0, then anything multiplied by 0 will be a 0. Then there is no significance of studying a GP. Secondly, if you are starting with a term and if you're multiplying it with 0, so every succeeding term will be 0. So both a and r should non-zero numbers. They can be negative, but they cannot be equal to 0. So this is how a standard GP looks like. So if we compare it with the AP, I said in AP this was like this, the general terminology. In this, the appearance is, instead of addition we are taking, see, we have used the word d here to denote the difference. We will use, instead of d, these a and these r, d and r, you can say they are both same things. A constant, fixed constant, which is basically modifying the sequence. So r here refers to common ratio. So it will go like this. It was increasing here in multiplication 2d, 3d, 4d. Here it will increase in terms of powers, because here we were adding, here we are repetitively multiplying the things. So this will be going like this. And what will be the, if we write the terms in terms of place value, so this will be a into r raised to power 0. So can I write this as 1 minus 1? This will be 2 minus 1, where 2 refers to its position. So for nth position, the general term will be a r n minus 1. So this is the perfect example. So this you can see, this is 3, second term is 3 into 2, third term is 3 into 2 square, fourth term is 3 into 2 cube, and hence. Okay, so this is the general term which I have just given it here. Okay, so let us have a look at how to find the sum of n terms. This is again very interesting. In AP we exploited that the sum from the back and the beginning, it was equal. Here we will exploit the thing that the terms are being multiplied by a constant. So if I write Sn, similarly this will be AR plus AR square plus AR n minus 1 plus, so this is the last term. So after this it will be AR. So we don't need to go to this term. We are interested in n terms. So we will write a term before this. So this will be a into r n minus 2. So now I'll tell you that why we are interested. So if I want to find the sum of n terms, so if I see that the terms, they are differing by a ratio r. So if I multiply this thing, the whole Sn by r, and shift the terms one step ahead. So can we get this will be AR, this will become AR square. Similarly, this here will be AR n minus 2. This term will be AR n minus 1 plus this term will become AR raised to power n. So now what was the purpose of doing it? Now if I subtract both these things, suppose if I name this as 1 and this as 2, and if I write 1 minus 2, so can we see that this all will get cancelled? So we have only two terms left to deal, that is the first and the last. Similar concept we will use when we will be doing the AGP, which we will be taking in next parts. So we will be using the same concept, so please keep this concept. So here it will be minus, okay? So this will be A into this. So from this you can write this as A into 1. This is again a very famous formula. Most of you have seen this in your textbooks or whatever books you are following. So this is again a very important formula. So in some books you might have seen that this formula it's valid when r is between -1 to 1, and they write r raised to power n minus r minus 1 for r greater than 1 or r less than -1. Basically, even if you use this formula, that will be holding true, because when r will be greater than 1, so this will be negative, this will again be negative. So you can write this. So this is basically equivalent form of this. So for convenience, you can remember this one only. For you don't need to worry about whether r is greater than 1. It will hold for every case. Let us see that what is sum of infinite terms in a GP means. In AP, why didn't we introduce this concept? Because in AP, if you go to infinite terms and if you are adding a constantly a term, so automatically you will approach infinity. But here there will be a case when the terms they are diminishing. What do I mean by diminishing? Means, suppose if I, in the earlier example, I took 3, 6. Suppose if I would have started by 48, 24, 12, 6, 3, 3 by 2, 3 by 4. Ultimately this term, they are getting smaller and smaller, and ultimately it will turn out to be approximately 0. So for this, if I take this to infinite terms, it has the significance. But so what we can see, what is the condition for this? So for this, to find the sum of infinite GP, the ratio should be less than 1 and should be greater than -1. Because if it's greater than 1, then the terms will get increased. If the ratio is less than -1, then again it will alternatively increase and decrease. So we cannot reach a final stage, and ultimately the magnitude will go on increasing. But if the ratio is between in fractions, broadly speaking, so in that case we will find a limiting case. Okay, so here what happens is your n is tending to infinity. The number of terms, I mentioned the infinite and finite sequences in the introduction part. So if n tends to infinity, the series becomes infinite. So we know that anything less between -1 to 1 raised to power infinity will tend to 0. Anything in this interval raised to power infinity will be equal to 0. So this term will be 1 minus 0, so it will be 1 only. So hence we get this formula. So keep in mind, this is only valid when your r is between -1 to 1. Otherwise you can use your common sense. Basically I have written here this thing, this will be 1 and this will be -1. So basically it will be holding true for this, because if r is greater than 1, then the terms will go on increasing and ultimately the sum will approach infinity. So this concept is only valid for r between -1 to 1. So let us have a look at some questions. Okay, so it says third term of an GP is 7. So A3, and what was that? A into r raised to power n minus 2. So it says find the product of, so n is here, if third term I am talking about, so you will substitute 3 here, so it will be this will be 1 here, sorry, so this will be AR square. So now it's asking product of first 5 terms. So let us first take the first 5 terms. So if I am saying AR square, not AR square, AR will be there, so it will be AR cube and AR4. Now if I multiply these, what will I get? This will be a raised to power 5. 5 a's are there. For r it will be 1 plus 2 plus 3 plus 4. So this will be 10. So a raised to power 5, r raised to power 10. So this will be ar square raised to power 5. So this is given to be 7. So automatically the product of these terms will become 7 raised to power 5. So important thing to note here was that we use the general term, and when we write the general term Tn or An, so according to this value of n, this expression will be defined, and rest when we do the questions we will use whatever is given in the question. Now this question uses the second important concept of this part, that the sum of the series plus the term infinite. So first we will see that what is given in the question. We will first analyze that, and then we will see that how to approach this problem. So this, if we clearly see that from here to here you are having suppose 2 raised to power 0, 2 raised to power 2, 1 by 2 raised to power 2, then again you are seeing here this is 2 raised to power 1, again decreasing, then again increasing to 3. So it means we are not going right. But if I see alternate terms, then 0 to 1, 2 to 4, then next term is 1 to 2, 4 to 6. Yes, now I get my GP as like this: 1 plus half plus 2 square, next term will be 2 cube, and it will go to infinity, and second GP will be 1 2 square plus 1 by 2 raised to power 4 plus, so both are GPs but both are having different ratios, and for this if I write first term it will be 1, for r it will be minus, not minus, 1 by 2, for this a will be equal to, the first term is here 1 by 2 this thing, and r will be equal to same thing. Okay, so now we are seeing that we have to find s infinity. So what I can write, this will be s infinity 1 and this will be s infinity 2. So this overall sum will be s infinity 1 plus s infinity 2. Now since the ratio is between minus 1 to 1 in both cases, this is 1 by 4 and 1 by 4 is obviously less than 1. So we can apply the formula which you remember was 1 a upon 1 minus r. So for first thing we know a is 1 and r is half. For second it's 1 by 2 square and 1 minus 1 by 2 square. So this on simplification, this will give you 2 and this will give you, if you solve it properly, 2 square by 2 square over 4 minus 1. So this will be 2 plus 1 by 3, which is equal to 7 by 3. So this is the answer. So we are seeing that we are getting a finite answer from an infinite terms. Isn't that interesting? It's because we are finding up to the limiting value. So these kind of series are known as convergent series, where the ratios or the ultimate, the infinite term, if you write a raised to power n minus 1 such that n tends to infinity, this will ultimately turn into 0. Why? Because this quantity, if it's between minus 1 to 1, this will become 0 and a into 0 will become 0. So where the final term is approaching towards 0, we can find the sum up to infinite terms. So this was all about the application plus the question part in GP. If you have any doubt in this topic, you can post it for free on askIITian website. For this, just visit the askIITian.com and there you can visit discussion board. It will direct you to Ask Expert, where you can select the category, and according to the category post your question and click the Get Answer button. Experts at askIITian will answer your query within 24 to 48 hours. So we have studied about the basics of geometric progression, and the important thing which we note here was that where AP was consisted of addition and subtraction, geometric progression consisted of multiplication and division. Plus there was a new concept in this, which was the sum of infinite terms, which we saw, and regarding that we have also discussed the question which I think have helped you in understanding the concept well. So we will see the next two parts of the GP in the subsequent lessons. So stay tuned.